Good morning. In discrete time system and signal processing subject, I am going to take a topic of classification of signals. First, what do you mean by signal? Signal means any physical quantity that varies with respect to time or space or any other independent variable. According to the signal, in the different features we have to classify the signal into 5 different types. The first one based on the independent variable. Second one depending upon the number of independent variable. The third one based on the mathematical rule. Fourth one based on the repetition nature. And fifth one based on the reflection. Already I told you that signal means any physical quantity that varies with respect to time. For example, we can take the speech is one of the signal. Now we have to identify whether the given signal is a continuous time signal or discrete time signal. According to the feature, we have to say that the speech signal is a continuous time signal because the signal is continuously varying with respect to time. Therefore, in the speech signal, the time is a independent variable. Therefore, the first point based on the independent variable, the signal can be classified into 2 different types. One is a continuous time signal, another one is a discrete time signal. Continuous time signal means the signal is continuously varying with respect to time. The example is speech signal. Then what about the discrete time signal? The discrete time signal is defined only for a particular time instant or the time integer, or we have to say that it's a time index. Sir, in the continuous time signal, we can represent the corresponding signal in the form of x of t. X be the function and t be the variable of the given function. Here, the time is an independent variable for the speech signal. In discrete time signal, we have to identify the corresponding signal in the form of x of n. Here also, x be the function, n be the independent variable, or you have to say that it is a time integer. Then how will you represent the continuous time signal and discrete time signal? Continuous time signal means, for example, you can take the speech or you can take the alternating voltage signal. The signal is continuously varying with respect to time. You have to draw the corresponding the graph here. The graph is drawn between the magnitude of the given signal and the time. The time is an independent variable here. Discrete time signal, better we can go for the digitized music signal is the best example for the discrete time signal. Because the signal is defined only for a particular time instant, or you have to say that it is a time integer. Therefore, you have to identify the corresponding signal. How will you identify it? So here also the graph is drawn between x of n and the independent variable time. I can take the corresponding time will be 0, 1, 2, 3. Like that we can take the integer number and identify the corresponding signal. The signal you have to draw a thick line and put the corresponding dot. The dot indicate the value of the given signal. Second one, depending upon the number of independent variable. Depending upon the number of independent variable, the signal can be classified into 3 different types. First one-dimensional signal. In one-dimensional signal, the function of the given signal depends on a single independent variable. Again, I have to take the same example, speech. Because the speech, the independent variable is a time. Therefore, the whole speech function depends on a time independent variable only. Second one is a 2-dimensional signal. 2-dimensional signal means the whole signal function depends on 2 independent variable. Then what is the best example of the 2-dimensional signal? We can take the black and white photographic signal. In black and white photographic signal, the whole signal function depends on the 2 independent variable. One is a black color, another one is a white color. Similarly, I have to go for the multi-dimensional signal. In a multi-dimensional signal, the signal function depends on a number of independent variable. But the best example is the color video signal, or you can take the color audio signal also. In the color video signal, the whole function depends on the black color, white color, and then you can take any other color combination from the RGB, and in the color video signal we can take one more independent variable. That independent variable is a speech, or you can take a time as a independent variable for the color video signal. The third one, depending upon the mathematical rule, the signal can be classified into two different types. One is a deterministic signal, another one is a random signal. Sir, in a deterministic signal, the signal that can be uniquely described by a well-defined process or some mathematical rule. The best example, you can take the alternating voltage signal. Generally, the alternating voltage signal, we have to say that V of t is equal to Vm sin omega t. But in mathematics, we have to express the corresponding value in the form of Vm into e power j omega t. The exponential term contains two different components. One is a cosine component cos omega t, another one is a sine component sin omega t. In your alternating voltage signal, generally the signal that can be described by a well-defined process or a mathematical rule. Here we have the two components, but in your alternating voltage we have to consider only one component, that is a sinusoidal component, because the DC generator, we have to see the corresponding, the output nature in the form of the sinusoidal nature only. Therefore, our study purpose, we can take V of t is equal to capital Vm into sin omega t. But what about the second nature? The second one is a random signal. The signal that cannot be generated in a random fashion, that can be generated in a random fashion, it cannot be predicted ahead of the time. The best example, you can take the ECG signal. The ECG signal, the output nature in the form of the random fashion only. Therefore, the ECG or EEG signals are the best example of the random signal. The fourth one, based on the repetition nature. Based on the repetition nature, the signal can be classified into two different types. One is a periodic signal, another one is a non-periodic signal. Periodic signal means if any signal satisfies the relation x of t is equal to x of t plus capital T, where capital T be the total time period, small t be the time independent variable. If the signal function satisfies x of t is equal to x of t plus capital T, then you have to say that the periodic signal. Otherwise, the signal, that is x of t, is not equal to x of t plus capital T, then you have to say that it is a non-periodic signal, right? Then you have to go to the last one, based on the reflection. Based on the reflection, again the signal can be classified into two different types. One is a odd signal, another one is a even signal. Odd and even signal. First I will take the even nature. Even signal. For example, you can take the continuous signal. In the continuous signal, we can take the corresponding, the original nature value. The original nature we have to draw like this only. X of t, we have to draw between x of t and t here. How will you define the even signal? Suppose if the signal function x of t is equal to x of minus t, then you have to say that the given signal is a even signal. What is x of minus t? X of minus t be the folding value of the original signal x of t. I want to draw the corresponding, what I call the waveform of the x of minus t. I will get the corresponding the even signal value. Here, this one is drawn between x of t and the time independent variable small t. But the other side, the third, in the second quadrant, we have to draw the corresponding characteristics curve. The characteristics curve is drawn between x of t and minus t. Therefore, I can say that if x of t is equal to x of minus t, then I can identify the given signal is a even signal. Then what about the odd signal? Odd signal means if the signal function, x of t is equal to minus x of minus t, then what I have to do is I have to draw the corresponding the waveform here. This is x of t. Now we can take the corresponding the folding value of the original signal x of t and take the reverse. Then I will get the corresponding the waveform like this. Therefore, this nature of the signal you have to say that odd signal. Now in the even and odd signal, we have the different properties suppose if the signal obeys the corresponding the properties, then we can easily identify the corresponding the continuous or the discrete nature of the even and odd signal. Thank you.